In today's tutorial, I will teach us how we can derive the estimate of the parameters or coefficients of a two-variable regression model. So, the topic for today is derivation of the least square estimates for two-variable regression model. Doing that, we have to establish the true relationship between the response variable y and the single regressor x. And that is y equals to a plus bx plus the error term. So here, from the right hand side, okay, given the three terms from the right hand side, a, bx plus mu, okay, the letter or the term mu stands for the surface variables in economics. It actually shows that all other factors or the determinants of what y are held constant. So that is why we include the term mu to take into consideration all the determinants of y variable. Okay, also from the right hand side, the a is the y-intercept, the b is the slope, mu is the error term. From the left hand side, y is the response variable. Okay, let us define this. And I'll say where y is where y implies the response variable. A implies y-intercepts. B implies slope or gradient. Mu implies the random variable or error term. Okay, so actually we can take the expectation of the response variable y, okay, and then such an expectation of the response variable will give us e of y equals to a plus bx. Okay, so we can say that the expectation of the response variable is given as what? E of y equal to a plus bx. Okay, so this particular expectation or the mean of y is what we call our true regression line. Our true regression line. Okay, so the estimate of our regression, okay, the estimate of our regression is, now say the estimate of this true regression is giving us y hat equal to a plus b hat x. Okay, so this equation here, the equation 3 here, okay, represents the estimates of the true regression equation given above. Okay, so we have that as what? Y hat plus a hat plus b hat x. Okay, so normal, we can still say that the estimate of the true relationship between the variables y and x is given as y equal to a hat plus b hat x plus the random term, or okay, let's say plus E, okay? Now let's define this, okay? Here, A hat implies estimated value of A. B hat implies the estimated value of what? The true parameter B. Then E implies that E is the residual. So the E implies the estimated value of the mu, that is the error term mu. Okay, so the E is the estimated value of mu. Okay, all right, so that is what we have as our estimated value of the true relationship between X and Y variables. Okay, so now, but we know that the E, which we call the residual, is equal to the E, which we call the residual, is equal to Y minus Y hat. Y minus Y hat. Okay? Let's go to equation 1. All right. But we recall that the Y hat normal is the estimate of our true regression line, okay? But Y hat is equal to A hat plus B hat X. Okay, so now we plug okay, Y hat. Well, we say that we plug A hat plus B hat X, okay, in equation 1 above. Okay, so doing that, we have E, that is the residual E, equal to Y minus, okay, minus bracket A hat plus B hat X. All right, okay. Now, the same way, we know that Y also is equal to A plus BX plus A plus BX plus mu. Okay? All right. Okay, but it's not necessary. Okay? We know what our Y value means already. That is the true relationship between the dependent variable Y and the independent variable X. Okay? So now, let us open the bracket of the residual above. Now say that E is equal to Y minus A hat minus B hat X. Okay? So that is it. So at this point, we shall try to minimize, okay, the sum square of this residual. All right? We shall try to minimize the sum of the square of this particular deviation. Okay, so let's say that we will have to what? First of all, square both sides of the equation. Okay, so now listen up, please. Okay, don't get this twisted. Okay, at this point now, what we shall use to create, okay, the normal equations, okay, is this residual. Okay, that is E equals to Y minus what? A hat minus B hat X. Okay, so now doing that now, okay, the step starts. Okay, the steps now starts. Okay, so having had this, okay, now we square both sides. Okay, well, let's call this equation 2. Okay, we square both sides of what? Equation 2. All right, so doing that, we have the residual squared equal to y minus a hat minus b hat x. Okay, raised to the power 2. All right, so let's call this our third equation, equation 3. Okay, so again, we take the sum of both sides of equation 3. We take the sum of what? Both sides. So doing that, we have summation e squared equal to summation equal to the summation of this binomial given above. Well, summation of the trinomial given above. Okay, so we have summation y minus a hat minus b hat x. All right. Okay, raised to the power 2. Okay. So now at this juncture, okay, well, let's call this equation 4 first of all. At this point, we have to what? Minimize this term square of the residual. Okay, we have to what? Minimize. How do we do so? We have to employ partial derivatives since we can see two different variables, y and what? X. Okay, normally, okay, but in this case, since what we are looking for is the estimate of the true parameter a and b, so we shall treat a hat and b hat as our what? Variables, as the unknown. Okay, because the true estimate is, or the estimate is what we are trying to what? Solve for. So we shall treat a cap or a hat as a variable, and also b cap or b hat as a variable. So that will make us to what? Employ the partial derivative. Okay, so doing that, we have to set every partial derivative of the squared residual with respect to the variables a hat and b hat equal to what? 0. That is, we will have to make the partial derivative of what? Summation e squared, okay, with respect to what? A hat and what? B hat undefined. And when something is said to be undefined, that thing is being set is equal to what? 0. Okay, so we now employ the partial derivative. Okay. All right, so doing that, we have the partial derivative of, okay, let's have from here, the partial please, okay, partial derivative of summation E squared with respect to partial derivative of A hat, okay, is equal to, so now differentiating summation E squared with respect to what? A hat, we shall have what? 0. Okay, but now let us differentiate first of all. Okay, at this point the type of derivative we shall use is generalized power function rule, or simply we can call it the chain rule. We can call it the what? Chain rule, or we can call it the generalized power function rule. Okay, so that is, we shall differentiate the expression itself and the expression inside the bracket or parenthesis. Okay, so now doing the derivative, we shall have -2 summation -2 summation, now parenthesis y minus A hat y minus A hat minus B hat x, okay, equal to 0. All right, so let us solve this. Okay, at this point, okay, where we differentiated using generalized power function rule or chain rule, we have -2 summation bracket y minus A hat minus B hat x. Okay, how did we get this? You can actually refer to the knowledge of your what knowledge of your what chain rule. Okay, okay, it means, let me explain this verbally. It means that we differentiated the expression itself, okay, to have 2 times, okay, the summation. We have 2 summation of the whole bracket. Okay, then we differentiated, since we are dealing with the respect of what? A hat. So we differentiated the expression inside, that is A hat, to have what? -1. That -1, we have to multiply the 2 summation, okay, to have what? -2 summation bracket what? Y minus A hat minus B hat x. Okay, then we set the whole result equal to what? 0, simply. So now we proceed. Okay, let's just say we divide. Okay, divide the equation above by 2. The equation by what? 2. Okay, to have, if we divide that, we shall obtain, okay, finally this. Okay, at this point, please let us deal with the right hand side. Okay, let us deal with the right hand side. Okay, yeah, because actually we said that we shall set equal to 0 partial derivative of what? Summation E squared over what? Summation partial derivation of what? A hat, okay, equal to what? 0. So we are now dealing with what? The right hand side. Okay, that is -2 summation bracket y minus A hat minus B hat x, okay, equal to 0. Okay, so now dividing by what? -2. Sorry, divided by what? -2. I obtain summation. I obtain summation bracket y minus A hat y minus what? A hat, okay, A hat minus B hat x equal to 0. Okay, so okay, let us expand this expression. Let us expand this. Okay, now expanding using what? Summation insignia or sign. We have summation times y is summation y. Summation times minus A hat is summation minus, sorry, is minus summation, sorry, is minus summation A hat. Okay, minus summation A hat. Okay, summation times beta hat x. We have minus summation, well, we can say summation x beta hat. Okay, well, we can say summation beta hat x. Anyone, they are asymmetrical, or they are symmetrical in mathematics. Okay, summation beta hat x. Okay, now equalizing it to what? 0. Okay, all right, let's still change this. Okay, let's do this way. Okay, summation times y is summation y. Summation times minus a hat. Okay, now it's summation a hat. Okay, summation times this is now, all right. So okay, I'm trying to check something. Okay, how it can be simplified to us and clear to us. Okay. All right. Okay. All right. So again, let's still simplify this. Okay. Let us say that summation insignia is equal to the observation n. Okay. Let's say that summation is equal to what? N. All right. So we have to substitute what? N in place of what? Summation alone. Okay. So and since a hat and b hat are variables, okay, so we will write this equation as what? Summation y. Please mind you, summation y is different, okay? Summation x is different, but so summation alone is what? N. Okay, so we have summation y equals to what? Summation y equals to what? N. Okay, where n is the coefficient now of a hat, okay, of a hat. A hat is now the variable to be solved for, okay. Sorry, I have not transposed. Okay, well, I have just transposed now, please, but please, let me do it very well, okay. Minus n a hat, okay, n a hat minus b, okay, let's say summation x b hat, okay, b hat, okay, equal to what? 0, equal to 0, okay. So now at this point, okay, we have a linear equation, okay, in two unknowns, and where the unknowns are what? A hat and b hat, okay. N is the coefficient of what? A hat. Summation x is what? B hat coefficient, okay. While summation y is treated as a constant. So now let us rearrange this equation. Let us what? Rearrange this equation, okay, and set it in a standardized form of what? Linear equation, okay, where the right hand side is a constant, okay. So in this case, we rearrange to have n a hat, okay, plus plus summation x b hat, okay, equal to summation y, okay. So let's call this equation A, okay. So the equation A here is a linear equation in two unknowns, where the unknowns are what? A cap and the b cap. The coefficients are n, summation x, and summation y. Summation y from the right hand side is treated as a constant, okay. N is what? Is the coefficient of what? A hat, and summation x is what? Coefficient of what? B hat, okay. So we go again by differentiating summation e square, okay, with respect to what? B hat, okay. So now we differentiate again, okay, to have the summation E squared the B hat, okay, that is the summation E squared summation that is partial derivative of what summation E squared with respect to what partial d of what B hat will give us okay, all right, so the result will be minus 2 summation x minus 2 summation x. Sorry, please, made a mistake here now. Okay, so minus 2, all right, summation okay, minus 2 summation x, okay, of y minus a hat minus b hat x, okay, equal to 0. All right, but normally we know that by zero factor property that each of the factor, okay, is equal to what 0, but we know that minus 2 is not equal to what 0, okay, so but without setting each of them equal to 0, let us do as we did in our first partial derivative, okay, and what did we do? We now said divide by minus 2. Okay, at this point we are taking only the right hand side, okay? All right, so doing that, okay, minus 2 cancel each step goes away, so we have summation x, okay, of summation x of y minus a hat minus b hat minus b hat, okay, x equal to 0. Okay, so now let us expand. Okay, we expand the parentheses using what summation x. Okay, so doing that we have summation x times y will give us summation xy. Okay, so summation x times a hat will give us summation x a hat. Okay, so all right, so I'm trying to check something, okay, so that we don't make a mistake. All right, okay, all right, so we have it as what summation x times minus a hat will give me summation a hat x. Okay, all right, summation a hat x, or simple summation x a hat. Okay, so we have summation x a hat. Okay, summation x a hat the same way goes to summation x times minus b hat x will give me what summation will give me summation x squared b hat, or b hat summation x squared. Okay, so whichever way you do so, it doesn't really matter. So we have summation s squared b hat. Okay, so equal to 0. Okay, so now let us rearrange this equation. Okay, like we said earlier, b hat and a hat are our what unknown. So let us put that in a standard form. Okay, where summation xy is our constant. Okay, so we have we have summation, summation x a hat, summation x a hat, okay, plus summation x squared plus summation s squared b hat equal to summation xy equal to summation xy. Okay, so let us call this equation B. Okay, so have you seen, actually we have derived two systems of linear equations in two unknowns, among which are a hat and what? B hat. Okay, so we shall solve them simultaneously using what? Matrix algebra, or our normal method of what? Elimination, or what? Substitution method. Okay, so but in this case, for simplicity, I think I will have to use matrix algebra. Okay, so let us bring out the equations, okay, together. So that is, we are bringing the equation A and B together. Okay, so having the equations, we have n a hat plus summation x b hat equal to summation y equal to summation y. Okay, that is our equation A given above. Again, the equation B, which we are seeing here already. Okay, let me still rewrite it out. Okay, so I have summation x b hat. I have summation x b hat plus summation s squared, summation s a hat plus summation s squared, summation s squared b hat equal to summation xy. Okay, so that is our non-equation B. So we will have to solve simultaneously using any method of our choice, okay, to solve for the values of what? A hat and what? B hat, which stands as our estimate of the true parameters of our regression model. Okay, so now let us establish 2 by 2 matrix equation. Okay, so doing that, we have, let's we have to write out the coefficient matrix. Okay, which is okay, the matrix is now n as one of our coefficients. Okay, and summation x and summation x. Okay, so all right, coming. All right, this one should be summation s squared, and this one, sorry, all right, is summation x. Okay, so again, we have our first unknown or variable a hat, and our second unknown or variable b hat equal to the vector or the constant vector from the right hand side, okay, which are what? Summation y, which are summation y and summation xy. Okay, so the equation above is a matrix equation. Okay, actually we have written out the unknowns and summation x from the first row of the coefficient matrix, and again from the second row of the coefficient matrix we have the coefficients to be summation x and summation x squared. Okay, so the still from the left hand side, okay, the unknowns are given as a hat and b hat. Then from the right hand side, the constant vectors are summation y and summation xy. Okay, so we have to employ Cramer's rule, that is Gabriel Cramer's rule, okay, to solve for the unknowns a hat and b hat. Okay, so without taking much of our time, okay, I'll have to solve for the determinants. Okay, I expect at this point you are supposed to have known how to manipulate a 2x2 matrix of this nature. Okay, so I'll have to what? Cross multiply the coefficient matrix and take their what? Difference. Okay, the difference of the entries, the difference of the products, okay, of the elements of our secondary diagonal will be subtracted from the product of the entries of our leading or main diagonal from our coefficient matrix at the left hand side. Okay, please. So I don't want to take much of our time. Okay, so let me do this. I have determinants. Okay, let me even call the matrix A. Okay, determinant of matrix A is given as n summation x squared n summation, n summation s squared, okay, minus, it means that n times, from the left hand side we have n times summation x squared, we have n summation x squared, then minus summation x times summation x, we have summation x all squared. Okay, so we have summation x all squared. Okay, so this becomes our what? Non-zero determinants. Okay, all right, so if not, it has the system has infinitely many solutions. Okay, so we have to replace, okay, the first column, okay, of our coefficient matrix with the right hand side vector. So doing that, we form a new matrix, okay, a new 2x2 what? Matrix. Okay, so here we have summation y, okay, summation y, again summation xy, okay, and we maintain the value of the second column, okay, which is summation x, and what? Summation x squared. Okay, summation x squared. All right, so let's call this matrix B, and we shall take its determinant as well. Okay, so determinant of matrix B is giving us summation y times summation s squared. Okay, will give me summation y summation s squared. Summation y times summation s squared. Well, I'm coming. Let me check something. Okay, summation y times summation s squared will give me summation y summation s squared, or in the other way around, summation s squared summation y. Okay, So they are the same thing. It doesn't really matter. For instance, x times y is xy or yx. So it doesn't really matter. They are symmetrical. Okay. So summation y times summation x squared is summation. Let me write summation x squared. Okay. Summation x squared summation y. All right. Sorry. Summation x squared summation y minus summation x times summation xy gives me summation x summation xy. Summation x summation xy. Please, what did I do? Okay, sorry, I didn't put the difference. Okay, so summation y times summation x squared is summation x squared summation y minus summation x times summation xy is what? Summation x summation xy. Okay, that becomes our what? Second determinant. Okay, we form the third determinant. All right. Okay, or simply we may just derive the value of what? Our first unknown. Okay, at this point we can now say that a hat, okay, a hat is equal to determinant of, that is, okay, the same way, determinant of what? A over determinant of what? B, which is equal to what we have, the determinants we derived, okay, above. Okay, so we have from the divisor, okay, we have n summation x squared, okay, n summation x squared minus summation x all squared minus summation x all squared. Okay, summation x all squared. Okay, that becomes our divisor. Okay, okay, and our numerator is summation s squared okay, sorry, summation s squared summation y minus summation x summation xy. Okay, so at this point, okay, the equation here, a hat represents the estimate of the true value of our what? True intercepts, okay, of our regression model, okay, A. So as you've seen, we have derived this, okay. So again, let us find for the estimate of what? B, that is beta or B hat, okay. So let's still, from our normal original coefficient matrix, okay, let us remove our second column entries, okay, and replace that with our right hand side vectors, okay. So that gives me matrix C, that gives me another matrix C, okay. So we call that N, okay. Let's have N. From here we have summation X, okay. The right hand side now becomes summation Y, okay. Again, summation X, summation XY, okay. All right. So let's call this matrix B. Let's call this matrix C, okay. So its matrix determination becomes n times summation xy, n times summation xy is n summation xy, okay. So we shall have n summation xy minus summation y times summation x will give us summation x summation y. Okay, so the value that is b hat, the value of our beta is now equal to determinant of our matrix B and determinant of our what? Matrix A, please, sorry. Or please, matrix C. Okay, determinant of our matrix A, please. All right, so thank you. So, please, there is a mistake here. Okay. There's a mistake here. Please, matrix A is our divisor. Please, matrix A is our divisor. Okay. Shit. Please don't get it twisted. Please, okay, don't be angry. Trying to correct something. Okay. Trying to just correct something. All right. Please, okay. All right, so this should be matrix B. Okay, that is matrix A is our divisor, that is our determinant. Okay, so for A hat we have matrix B divided by what? Matrix A. Okay, we got that in our based on our normal abstract, but based on the determinants, okay, which we place inside the absolute bar, we made a mistake, so which I have just corrected right now. Okay, so thank you. So we have again, where did we stop? Okay, so all right. So B hat value is equal to determinant of matrix C over that of what? Matrix A, which is equal to okay, all right, from the divisor we have our normal determinant value, which is n summation s squared, n summation s squared minus summation x all squared, sorry, minus summation x all squared. Okay, all squared. You say that it is n summation x squared, okay, minus summation x all squared. That is our divisor. Our numerator or dividend becomes n summation xy minus summation x summation y. Okay, so this one becomes the value or the estimate of our true parameter, or well, slope, okay, b, okay, from our equation. So have you seen how actually we can derive the estimate of the true value of the parameters a and what b given in our regression model or equation? Okay, using by minimizing the sum square of our residual. Okay. Again, there is with another formula we can still use. Okay, which is deviation from the mean. Okay, but well, that may be done in our next tutorial. Okay, or subsequent tutorials. Okay, by Makasi Chinedu. Hope this helps. By Makasi Chinedu. Makasi. Please subscribe to my YouTube channel for tutorials in mathematics, econometrics, economics, and quantitative economics. I am responsible for any verbal error or mistake or typographical error found in this video. Thank you so much. Thank you for watching.